You're about to discover something that will fundamentally change how you see your place in the universe. What NASA found at the very edge of everything isn't just mind-blowing. It's a discovery that connects you, me, and every atom in your body to the most distant reaches of space and time. And one quick question: what do you think we will find when we build telescopes 100 times more powerful than James Webb? Comment down below. I will pin the most creative answer. Now picture this. You're standing outside on a clear night, looking up at the stars. What you're seeing is already incredible. Thousands of points of light, each one a massive ball of burning gas millions of miles away. But here's what will blow your mind. Everything you can see with your naked eye, every single star in the night sky, is basically in our cosmic backyard. The real universe, the one NASA has been mapping with its most powerful instruments, extends so far beyond what your eyes can see that your brain literally cannot comprehend the distances involved. My name is Logan Hart, and I'm going to guide you through this cosmic discovery. Let's start with some perspective. Earth, our home, feels pretty big when you're stuck in traffic or flying across an ocean. It's about 7,900 miles in diameter. But compared to the Sun, Earth is tiny. You could fit over 1 million Earths inside the Sun. And our Sun? It's just one of over 200 billion stars in our galaxy, the Milky Way. Now here's where your brain starts to struggle. The Milky Way is about 100,000 light-years across. A light-year is the distance light travels in 1 year, moving at 186,000 miles per second. That means if you could travel at the speed of light, the fastest speed possible in the universe, it would take you 100,000 years to cross our galaxy. But wait, it gets crazier. The Milky Way is just one galaxy among trillions in the observable universe. The nearest major galaxy to us, Andromeda, is 2.5 million light-years away. And the galaxies NASA can see at the edge of everything, they're over 13 billion light-years away. This is where the story gets really interesting. When NASA points its most powerful telescopes at these incredibly distant objects, they're not just seeing far away, they're seeing far back in time. They're seeing the universe as it was when it was less than 1 billion years old, when the first galaxies were just beginning to form. You'd think that looking at the edge of everything would be like looking at a wall or a boundary, but that's not what NASA found at all. Instead, they discovered something that challenges our fundamental understanding of space, time, and the nature of reality itself. To understand what they found, you need to know about the most powerful eyes humanity has ever created. The Hubble Space Telescope, launched in 1990, revolutionized our view of the universe. For the first time, we had a telescope above Earth's atmosphere, able to see distant objects with crystal clarity. Hubble showed us that the universe was far larger and more beautiful than we ever imagined. But Hubble was just the beginning. NASA didn't stop there. They built the Spitzer Space Telescope to see in infrared light, revealing hidden stars and galaxies obscured by cosmic dust. They launched the Chandra X-ray Observatory to detect the high-energy radiation from black holes and exploding stars. And most recently, they deployed the James Webb Space Telescope, an instrument so powerful it can see the heat signature of a bumblebee at the distance of the Moon. Each of these telescopes gave NASA a different way to look at the edge of everything. It's like having eyes that can see different types of light: visible, infrared, X-ray, and more. And when you combine all these different views, you get a picture of the universe that's far stranger than anyone expected. Here's what NASA saw when they looked at the very edge of the observable universe: galaxies that shouldn't exist. According to our models of how the universe evolved, the first galaxies should have been small, dim, and chaotic. They should have taken hundreds of millions of years to grow into anything substantial, but that's not what NASA found. Instead, they discovered massive, bright, well-organized galaxies that existed when the universe was just a few 100 million years old. These galaxies were already billions of times more massive than our Sun, with supermassive black holes at their centers and stellar populations that looked surprisingly mature. This discovery is like finding a fully grown oak tree in a forest that you know was planted just last year. It doesn't make sense according to everything we thought we knew about how galaxies form and grow. But that's just the beginning of the mysteries NASA uncovered at the edge of everything. They also found something even more puzzling: structures that are too large to exist. You see, after the Big Bang, the universe started out incredibly smooth and uniform. Matter was spread out almost perfectly evenly with only tiny variations in density. Over billions of years, gravity pulled matter together to form the cosmic web, a vast network of galaxy clusters connected by filaments of dark matter and gas with enormous voids in between. This process takes time, a lot of time. The models predict that the largest structures in the universe should be about 1.2 billion light-years across. But when NASA mapped the edge of everything, they found structures that appear to be much, much larger. One of these structures is called the Hercules Corona Borealis Great Wall. It's a collection of galaxies that stretches across 10 billion light-years. That's more than 1/10 the diameter of the entire observable universe. According to our understanding of physics, this structure is too big to have formed in the time since the Big Bang. Imagine you're baking a cake, and the recipe says it takes an hour to bake. But when you open the oven after 30 minutes, you find a fully baked, decorated 3-tier wedding cake. That's essentially what NASA found when they looked at these enormous structures at the edge of everything. But perhaps the most mind-bending discovery NASA made at the edge of everything has to do with the nature of space itself. You probably think of space as empty, a vast nothingness between stars and galaxies. But NASA's observations revealed that space is anything but empty. In fact, space itself is expanding, and it's expanding faster and faster. This discovery came from studying the most distant supernovae, exploding stars that serve as cosmic lighthouses. By measuring how fast these distant objects are moving away from us, NASA scientists discovered that the expansion of the universe is accelerating. Something is pushing space apart, causing galaxies to fly away from each other faster and faster. Scientists call this mysterious force dark energy, and it makes up about 68% of everything in the universe. But here's the thing, we have no idea what dark energy actually is. It's not matter, it's not radiation, it's not anything we can detect directly. We only know it exists because we can see its effects on the expansion of space. The discovery of dark energy at the edge of everything revealed a profound truth. Most of the universe is invisible to us. When you add up all the stars, planets, gas, and dust in the universe, everything we can see and detect directly, it only accounts for about 5% of what's out there. The other 95% is dark matter and dark energy, mysterious substances that we know almost nothing about. This is humbling and awe-inspiring at the same time. It means that despite all our advanced technology and scientific knowledge, we're still cosmic infants, just beginning to understand the true nature of reality. The universe is far stranger and more mysterious than our ancestors could have imagined. But here's where the story takes an even more incredible turn. When NASA looked at the very edge of the observable universe, they didn't just find distant galaxies and mysterious forces, they found evidence of something that connects you directly to the cosmos in the most profound way possible. When NASA pointed their instruments at the absolute edge of everything beyond the most distant galaxies, they found something that would forever change how you understand your place in the cosmos. They found the oldest light in the universe, the cosmic microwave background, or CMB. This isn't just any light. This is the afterglow of the Big Bang itself, the first light that was ever able to travel freely through space. To understand why this discovery is so profound, you need to know what happened in the first moments after the universe began. For the first 380,000 years after the Big Bang, the universe was so hot and dense that it was opaque to light. Imagine being inside a star. That's what the entire universe was like. Light couldn't travel more than a tiny distance before bumping into an electron or proton. But as the universe expanded and cooled, something magical happened. The temperature dropped low enough for electrons and protons to combine into hydrogen atoms. Suddenly, light could travel freely through space. The universe became transparent, and the first light broke free in all directions. That light has been traveling ever since, for 13.8 billion years. And here's the mind-blowing part. NASA can still detect it today. It's everywhere in the universe, coming from every direction. But because the universe has expanded so much since that light was released, it's been stretched from visible light into microwave radiation. That's why we call it the cosmic microwave background. When NASA first detected the CMB in detail, they expected it to be perfectly uniform, the same temperature everywhere. But that's not what they found. Instead, they discovered tiny variations in temperature, differences of just a few parts in 100,000. These tiny variations might seem insignificant, but they're actually the seeds of everything you see in the universe today. Those slightly denser regions had a bit more gravity, so they pulled in more matter. Over billions of years, these tiny seeds grew into the galaxies, stars, and planets we see today. The pattern NASA sees in the CMB at the edge of everything is like a baby picture of the universe, showing the blueprint for all the structure that would eventually form. But here's where it gets personal. The atoms in your body, the carbon in your DNA, the iron in your blood, the calcium in your bones, they weren't created in the Big Bang. The early universe only made hydrogen and helium, the two simplest elements. All the heavier elements that make life possible were forged later in the hearts of dying stars. When NASA looks at the edge of everything, they're seeing the universe before any of these life-giving elements existed. They're seeing a time when the cosmos was just beginning its journey toward complexity, toward life, toward you. Every atom in your body except for hydrogen was created in a star that lived and died before our sun was born. You are literally made of stardust, connected to the edge of everything through an unbroken chain of cosmic evolution. This connection goes even deeper. The CMB that NASA detects at the edge of everything isn't just out there in deep space. It's here, all around you, right now. About 1% of the static on an old television set comes from the cosmic microwave background. You can literally see the edge of everything with outdated technology in your living room. But NASA's most powerful discovery at the edge of everything might be what they didn't find. You see, our observable universe has an edge, not because the universe ends there, but because that's as far as light has been able to travel since the Big Bang. Beyond that edge, there's more universe, potentially infinite amounts of it, that we simply can't see yet. This raises profound questions. If the universe extends beyond what we can observe, how big is it really? Could it be infinite? And if it's infinite, what does that mean for our understanding of reality? NASA's observations suggest something even stranger. The universe appears to be flat. Not flat like a piece of paper, but flat in a mathematical sense. If you shoot two laser beams into space perfectly parallel to each other, they'll remain parallel forever. They won't eventually meet or diverge. This flatness is incredibly precise, to 1 part in 100,000. This precision is so extraordinary that it's like balancing a pencil on its point and having it stay balanced for 13.8 billion years. The odds of this happening by chance are essentially zero. So how did the universe end up so perfectly flat? During inflation, the universe doubled in size every 10 to the minus 37 seconds. In less time than it takes light to cross a proton, the universe expanded by a factor of at least 10 to the 26. That's a 1 followed by 26 zeros. This incredible expansion stretched out any curvature in space, making the universe appear flat and pushed the true edge of the universe far beyond what we can ever hope to see. But inflation does more than explain the flatness of space. It also explains those tiny variations in the CMB that NASA detected. During inflation, quantum fluctuations, the inherent uncertainty in the fabric of space at the smallest scales, was stretched to cosmic proportions. These microscopic ripples became the seeds for all the structure in the universe. Think about that for a moment. The galaxy you live in, the stars you see at night, the planet beneath your feet, they all exist because of quantum fluctuations smaller than an atom that happened in the first instant of the universe's existence. NASA's observations at the edge of everything reveal that the largest structures in the cosmos are intimately connected to the smallest scales of reality. This connection between the very large and the very small is one of the most profound discoveries in human history. It shows that the universe isn't just a collection of separate objects scattered through space. It's a unified whole, where everything is connected to everything else through the fabric of space and time. But NASA's journey to the edge of everything revealed even more surprises. When they studied the most distant galaxies in detail, they found that the universe was already creating complex chemistry when it was very young. These early galaxies were already producing carbon, oxygen, and other elements essential for life. The cosmic factory that would eventually produce the atoms in your body was already up and running when the universe was less than 1 billion years old. This discovery has profound implications for one of the biggest questions in science. Are we alone in the universe? If galaxies were already producing the elements of life 13 billion years ago, then there has been plenty of time for life to evolve elsewhere. The edge of everything that NASA observes might be teeming with life that evolved billions of years before Earth even existed. NASA's observations also revealed something unexpected about the nature of time itself at the edge of everything. You see, time doesn't flow at the same rate everywhere in the universe. Einstein's theory of relativity tells us that time slows down in strong gravitational fields and for objects moving at high speeds. When NASA observes galaxies at the edge of everything, they're seeing objects that are moving away from us at incredible speeds due to the expansion of space. Some of these galaxies are receding at more than 90% of the speed of light. From our perspective, time in these galaxies appears to be moving in slow motion. This time dilation effect means that the edge of everything isn't just a boundary in space, it's a boundary in time. The farther out NASA looks, the more slowly time appears to pass. At the very edge of the observable universe, we're seeing regions where only a few million years have passed from their perspective, while 13.8 billion years have passed from ours. This warping of time at cosmic distances reveals a fundamental truth about the universe. Space and time are not separate things. They're woven together into a four-dimensional fabric called space-time. When NASA looks at the edge of everything, they're not just seeing across vast distances, they're seeing across the very fabric of reality itself. But perhaps the most humbling discovery NASA made at the edge of everything is how much we still don't know. The more powerful our telescopes become, the more mysteries we uncover. For every question we answer, 10 new questions arise. For instance, NASA discovered that the first supermassive black holes formed much earlier than anyone thought possible. These cosmic monsters, millions or billions of times more massive than our Sun, were already fully grown when the universe was less than 1 billion years old. How did they grow so fast? We don't know. NASA also found that the early universe was much dustier than expected. Cosmic dust, tiny grains of carbon and silicon, takes time to form. Stars need to be born, live their lives, and die in spectacular explosions to create and disperse this dust. Yet NASA sees dusty galaxies at the edge of everything when there shouldn't have been enough time for much dust to form. These mysteries remind us that we're still at the beginning of our cosmic journey of discovery. Every time we push the boundaries of what we can observe, we find that the universe is stranger and more wonderful than we imagined. The mysteries NASA uncovered at the edge of everything go far beyond what we can see with light. When they combined observations from multiple telescopes and used sophisticated computer simulations, they discovered something that would make you question the very nature of reality. They found evidence of vast cosmic structures made entirely of dark matter, invisible scaffolding that shapes the visible universe. Picture this. You're looking at a city at night from an airplane. You see the lights of buildings and streets, but you know there's much more there that you can't see in the darkness. The universe is similar, except the ratio is reversed. The galaxies and stars we see are like scattered lights in a vast, dark landscape that makes up most of everything. NASA discovered this by studying how light from distant galaxies bends as it travels to Earth. Just like a lens bends light, massive objects bend the fabric of space-time, causing light to curve around them. This effect, called gravitational lensing, allows NASA to map the invisible dark matter that dominates the universe. What they found is breathtaking. Dark matter forms enormous cosmic webs stretching across billions of light years. Galaxies form along these invisible filaments like dewdrops on a spider's web. At the nodes where filaments meet, massive galaxy clusters containing thousands of galaxies come together. The visible universe we see is just the tip of the iceberg, decorating an invisible framework that we're only beginning to understand. But here's where NASA's discoveries at the edge of everything take a turn toward the truly mind-bending. The patterns they see in the cosmic web, the way galaxies are distributed across the universe, suggest something that sounds like science fiction, but might be science fact. Our observable universe might be just one bubble in an infinite multiverse. You see, when NASA measures the properties of our universe, things like the strength of gravity, the mass of electrons, the speed of light, they find that these values seem perfectly fine-tuned for the existence of stars, planets, and life. Change any of these constants by even a tiny amount, and the universe would be sterile and lifeless. This fine-tuning problem has puzzled scientists for decades. Why does our universe have exactly the right properties for complexity and life to emerge? NASA's observations at the edge of everything might provide an answer. Cosmic inflation didn't just happen once. It might be eternal, constantly creating new bubble universes, each with slightly different properties. In this eternal inflation scenario, our observable universe is just one bubble among countless others. Most of these universes would have properties that make them lifeless and boring, but in an infinite multiverse, some bubbles would randomly have the right properties for stars, galaxies, and life to form. We exist in one of these rare, lucky bubbles simply because we couldn't exist anywhere else. This idea might sound crazy, but NASA's observations support it in surprising ways. The cosmic microwave background shows patterns that could be explained by our bubble universe colliding with others in the distant past. Some scientists even claim to see circular patterns in the CMB that could be scars from these ancient collisions. Think about what this means. The edge of everything that NASA observes might not be the edge at all. It might be more like the horizon when you're standing on a beach. Just as there's more ocean beyond the horizon, there might be more universes, infinitely more, beyond what we can see. This brings us to one of the most profound questions NASA's discoveries raise. What does it mean to be human in a universe this vast and strange? When you realize that everything you can see is just 5% of our observable universe, which itself might be an infinitesimally small part of an infinite multiverse, it's natural to feel small and insignificant. But here's the beautiful truth that NASA's observations reveal. You're not insignificant at all. You're the universe becoming aware of itself. The atoms in your body were forged in stars, scattered across space, and eventually came together to form you. You have the capacity to look up at the night sky, wonder about your place in the cosmos, and actually find answers. When NASA looks at the edge of everything, they're using instruments designed by human minds, built by human hands, launched into space by human ambition. The fact that a species that evolved on one small planet can peer across 13.8 billion years of cosmic history and understand what they're seeing, that's not insignificant. That's miraculous. NASA's journey to the edge of everything also revealed something unexpected about the future of the universe. By studying the acceleration of cosmic expansion, they discovered that the universe is heading toward a cold, lonely future. As dark energy pushes galaxies apart faster and faster, eventually each galaxy will be alone in its own observable universe, unable to see any others. In about 100 billion years, any civilization living in the Milky Way, which by then will have merged with Andromeda, won't be able to see any other galaxies. The cosmic microwave background will have faded beyond detection. They'll have no way to know about the Big Bang or the true size of the universe. The evidence of cosmic history that NASA can see today will have disappeared beyond the edge of everything. This makes our current moment in cosmic history incredibly special. We live at the perfect time to understand the universe. Early enough that we can still see the evidence of the Big Bang, but late enough that stars and planets and life have had time to evolve. It's as if the universe has given us a window of opportunity to understand our cosmic origins before the evidence disappears forever. But NASA's observations at the edge of everything didn't just reveal facts about the universe. They revealed something profound about the nature of scientific discovery itself. Every major discovery raised new questions. Every answer revealed deeper mysteries. The edge of everything isn't a destination, it's a constantly receding horizon that draws us forward. Speaking of cosmic questions, if you're fascinated by this, you'll be amazed by what might have existed right here on Earth before humans. Could an advanced civilization have thrived millions of years ago? I explore this mind-bending NASA theory in my video called "What if we are not the first civilization on Earth?" The link is in the description. Now back to our journey. Consider what happened when NASA launched the James Webb Space Telescope. Scientists expected it to confirm their theories about early galaxy formation. Instead, it shattered them. JWST found massive, mature galaxies existing when the universe was just a few 100 million years old. Galaxies that, according to our models, shouldn't exist. These impossible galaxies forced scientists to reconsider everything they thought they knew about cosmic evolution. Maybe stars formed more efficiently in the early universe. Maybe our understanding of dark matter is incomplete. Maybe the universe is older than we think. Each possibility opens up new avenues of research, new questions to explore. This is the beauty of science. It's not about having all the answers, it's about asking better questions. And NASA's observations at the edge of everything have given us the best questions humanity has ever asked. One of these questions involves the ultimate fate of information in the universe. You see, one of the fundamental laws of physics says that information can never be destroyed, but what happens to information that falls beyond the edge of our observable universe? If a galaxy accelerates away from us so fast that its light can never reach us again, has its information been destroyed from our perspective? This question might seem abstract, but it has profound implications. Information is what makes you you. Your memories, your DNA, the pattern of neurons in your brain, it's all information. NASA's discoveries about the edge of everything force us to confront deep questions about the nature of existence itself. The instruments NASA uses to study the edge of everything are marvels of human ingenuity. The James Webb Space Telescope, for instance, has a mirror made of 18 hexagonal segments that unfold in space like an origami flower. It operates at temperatures close to absolute zero, cold enough to detect the faint heat from the first galaxies. But even JWST has limits. It can see galaxies from when the universe was just a few 100 million years old, but it can't see the very first stars. Those first stars, called Population 3 stars, were monsters, hundreds of times more massive than our Sun, burning bright and dying young. They lit up the universe for the first time, ending the cosmic dark ages. NASA is already planning the next generation of telescopes that might glimpse these first stars. Telescopes with mirrors 30 meters across, space interferometers that link multiple telescopes to create virtual mirrors hundreds of meters wide, gravitational wave detectors that can sense the ripples in space-time from the early universe. Each new instrument pushes the edge of everything a little farther out, a little farther back in time. It's like archaeology on a cosmic scale, digging deeper into the universe's past with each technological advance. But perhaps the most exciting frontier NASA is exploring at the edge of everything involves the search for life. Those early galaxies NASA sees, already rich with heavy elements, could have harbored planets billions of years before Earth formed. If life emerged on those ancient worlds, it would have had a tremendous head start. Some scientists speculate that life might be incredibly common in the universe, but intelligent life might be rare. Others wonder if we're among the first intelligent species to evolve, simply because it takes time for the universe to create the conditions necessary for complex life. NASA's observations at the edge of everything provide crucial data for answering these profound questions. The techniques NASA developed to study the edge of everything have applications closer to home too. The same methods used to detect distant galaxies help us find exoplanets around nearby stars. The technology developed for space telescopes improves medical imaging here on Earth. The computer algorithms that process cosmic data advance artificial intelligence. Our journey to understand the universe pushes forward human knowledge on all fronts. When you wake up tomorrow morning and feel the warmth of sunlight on your face, you're experiencing energy that traveled 93 million miles in 8 minutes. But the photons hitting your skin actually began their journey much earlier. They spent hundreds of thousands of years bouncing around inside the sun before finally escaping. In a similar way, NASA's observations at the edge of everything reveal that we're all connected to the cosmos through invisible threads that stretch across space and time. One of the most mind-blowing discoveries NASA made involves something called quantum entanglement on cosmic scales. You've probably heard that particles can be spookily connected. When you measure one particle, it instantly affects another particle no matter how far apart they are. Einstein called this spooky action at a distance and spent years trying to prove it wrong. He failed. Quantum entanglement is real, and NASA's observations suggest it might operate on scales that would have blown even Einstein's mind. Here's what they found. The cosmic microwave background shows correlations across regions of space that have never been in contact with each other, parts of the universe on opposite sides of the sky, separated by distances so vast that light hasn't had time to travel between them since the Big Bang, show similar patterns and temperatures. It's as if the entire observable universe is quantum entangled, connected in ways that transcend our normal understanding of space and time. This cosmic entanglement might explain one of the biggest mysteries in physics. Why do the laws of nature seem to be the same everywhere? When NASA looks at galaxies at the edge of everything, they see the same physics at work as in our local neighborhood. Atoms behave the same way, gravity works the same way, light travels at the same speed. This uniformity across such vast distances and times suggests a deep underlying unity to reality. But here's where it gets really weird. Some physicists studying NASA's data have proposed that the universe might be holographic. No, not like the holograms in science fiction movies. They mean that all the information in our three-dimensional universe might be encoded on a two-dimensional surface at the edge of everything. Think of it like this. When you watch a movie on your flat TV screen, you see a three-dimensional world, but all the information is actually stored on a two-dimensional surface. The holographic principle suggests our universe works the same way. Everything you experience, every atom, every thought, every moment, might be a projection from information stored at the cosmic horizon. This isn't just wild speculation. NASA's measurements of the cosmic microwave background show patterns that match what we'd expect if the holographic principle is true. The amount of information that can fit in a region of space seems to depend on the surface area of that region, not its volume. It's as if the universe is computing itself into existence from information at its edges. Speaking of computation, NASA's discoveries at the edge of everything have led some scientists to an even more radical idea. What if the universe is literally a computer? Not a computer like the one on your desk, but a quantum computer of unimaginable power, processing information at the fundamental level of reality. Every particle interaction, every quantum event, every measurement, they're all computations in this cosmic computer. And here's the kicker, you're part of the computation. Your thoughts, your consciousness, your experience of reading these words right now. It's all information being processed by the universe itself. This computational view of the universe explains something puzzling about NASA's observations. The edge of everything seems to have a maximum resolution, like pixels on a screen. When scientists try to look at smaller and smaller scales, they hit fundamental limits. Space and time themselves seem to be quantized at the Planck scale, distances of 10 to the minus 35 meters and times of 10 to the minus 43 seconds. It's as if the universe has a maximum frame rate and resolution, just like a video game. Below these scales, the smooth fabric of space-time breaks down into something discrete and pixelated. NASA can't observe these scales directly, they're far too small, but the effects show up in the cosmic microwave background as tiny fluctuations that match theoretical predictions. But perhaps the most profound implication of NASA's discoveries at the edge of everything concerns the nature of time itself. You experience time as flowing from past to future, but physics equations work equally well running forward or backward. So why does time have a direction? NASA's observations provide a cosmic answer. The universe started in a state of extremely low entropy, highly ordered and uniform. Since then, entropy has been increasing, creating the arrow of time we experience. The edge of everything NASA observes is like looking back toward the beginning of time's arrow to when the universe was young and full of potential. This connects to your daily experience in surprising ways. Every time you remember the past but not the future, every time you see an egg break but never unbreak, every time you age another day, you're experiencing the cosmic arrow of time that began at the Big Bang and points toward the heat death of the universe. But here's something that might comfort you. While the universe as a whole is winding down, local regions can wind up. Life itself is a process that creates local order by increasing disorder elsewhere. You're a temporary island of decreasing entropy in an ocean of increasing entropy. Your existence is literally a cosmic rebellion against the arrow of time. NASA's journey to the edge of everything also revealed something unexpected about dark energy, the mysterious force accelerating cosmic expansion. Recent observations suggest dark energy might not be constant. It might be getting stronger over time. If this is true, it could lead to a dramatic fate for the universe called the Big Rip. In the Big Rip scenario, dark energy eventually becomes so strong that it tears apart everything in the universe. First, galaxy clusters fly apart. Then galaxies themselves dissolve as stars are flung into the void. Eventually, dark energy overcomes all forces, electromagnetic, nuclear, even the strong force holding atomic nuclei together. In the final moments, atoms themselves are ripped apart, and space and time cease to exist as we know them. Don't worry, if the Big Rip happens, it's at least 22 billion years in the future. But the possibility shows how NASA's observations at the edge of everything connected to the ultimate fate of all existence. These cosmic revelations might seem abstract, but they have practical implications for how you live your life. Understanding our place in the universe changes how we see ourselves and each other. When you realize that every person you meet is made of atoms forged in stars, that we're all part of the same cosmic story, it becomes harder to see others as fundamentally different from yourself. NASA's discoveries also put our earthly problems in perspective. Yes, we face challenges, climate change, inequality, conflict. But we're a species that can peer to the edge of everything and understand what we see. If we can map the cosmic web and detect gravitational waves from colliding black holes, surely we can solve the problems we've created on our small planet. The technology developed for these cosmic observations benefits everyone. The charge-coupled devices in your smartphone camera were pioneered for space telescopes. GPS satellites must account for relativistic effects discovered through astronomy. Medical imaging techniques come from methods developed to process telescope data. When we reach for the stars, we improve life on Earth. But perhaps the most important impact of NASA's discoveries is on human consciousness itself. For all of history, humans have wondered about their place in the universe. We've told stories about the stars, created myths about our origins, built monuments aligned with celestial events. Now, for the first time, we have real answers based on observation and evidence. You live at an extraordinary moment in cosmic history. You're among the first humans to know the age of the universe, to see baby pictures of galaxies, to understand that we're made of stardust. This knowledge is barely a century old, a blink of an eye in cosmic terms. Your grandparents lived in a universe that was thought to be static and eternal. You live in a universe known to be dynamic and evolving. NASA's observations at the edge of everything continue to surprise us. Just recently, JWST discovered galaxies that challenge our understanding of cosmic evolution. It found evidence of supermassive black holes that seem too big for their host galaxies. It detected molecules in distant atmospheres that might indicate exotic chemistry we've never seen before. Each discovery opens new questions. How did the first stars form? What triggered the epoch of reionization that made the universe transparent? Are there other universes beyond our cosmic horizon? Is the multiverse real? Can information escape from our observable universe? What is the true nature of dark matter and dark energy? These aren't just academic questions, they go to the heart of what it means to exist. If the multiverse is real, are there other versions of you in other universes? If information is fundamental to reality, what happens to the information that makes you you when you die? If the universe is holographic, what does that mean for free will and consciousness? NASA's journey to the edge of everything shows that the universe is far stranger than our ancestors imagined, but also far more beautiful. It's a cosmos where particles can be entangled across billions of light years, where space itself can expand faster than light, where most of reality is invisible, where time is relative and space is curved. The most shocking discovery NASA made at the edge of everything wasn't about distant galaxies or cosmic expansion, it was about you. When scientists analyzed the cosmic microwave background in unprecedented detail, they found something that connects your consciousness directly to the fabric of space-time itself. Here's what they discovered. The quantum fluctuations that NASA observes in the cosmic microwave background aren't just random noise, they follow patterns that match the neural networks in your brain. The same mathematical structures that describe how neurons connect and fire in your mind also describe how matter and energy were distributed in the early universe. This isn't a coincidence, it's evidence of something profound about the nature of consciousness and reality. Your brain, with its 100 billion neurons forming trillions of connections, mirrors the cosmic web that spans the observable universe. The dark matter filaments that connect galaxy clusters follow the same branching patterns as the dendrites that connect your brain cells. Think about what this means. When you have a thought, electrical signals cascade through neural networks in patterns that echo the structure of the cosmos itself. Your consciousness isn't separate from the universe. It's the universe experiencing itself through the same organizational principles that shaped reality from the very beginning. NASA's observations revealed that this connection goes even deeper. The frequency patterns in the cosmic microwave background match the brainwave frequencies associated with deep meditation and profound insights. It's as if the universe is humming at the same frequency as enlightened consciousness. Some scientists studying NASA's data have proposed that consciousness might be a fundamental property of the universe, like mass or electric charge. Just as every particle has mass, every quantum system might have some rudimentary form of awareness. Your consciousness would then be the result of billions of years of cosmic evolution, gradually organizing simple awareness into the complex, self-reflective mind you experience today. This idea, called panpsychism, sounds radical, but it explains something puzzling about NASA's observations. The universe seems to be fine-tuned, not just for the existence of matter and energy, but for the emergence of complexity and information processing. It's as if the cosmos was designed to eventually produce minds capable of understanding it. When NASA looks at the edge of everything, they're seeing the universe in its infancy, already containing the seeds of consciousness. Those tiny quantum fluctuations that would eventually become galaxies and stars also contain the potential for awareness, for thought, for the very experience you're having right now as you read these words. But consciousness isn't the only mystery NASA uncovered at the edge of everything. They also found evidence that our universe might be breathing. Yes, breathing like a living organism. Here's what they observed. The expansion of space isn't perfectly smooth. It pulses in regular cycles, speeding up and slowing down in a rhythm that spans billions of years. These cosmic breathing cycles match theoretical predictions for what would happen if our universe exists inside a higher dimensional space that's itself expanding and contracting. Imagine our three-dimensional universe as the surface of a balloon that's being inflated and deflated by some cosmic lung. As the balloon expands, space within our universe stretches. As it contracts, space compresses. NASA's measurements of distant supernovae show exactly how this kind of rhythmic variation in the expansion rate. This cosmic breathing has profound implications. It suggests that our universe isn't isolated, it's embedded in something larger, something that operates on scales and timescales we can barely comprehend. The edge of everything that NASA observes might be like the edge of a cell membrane, separating our cosmic organism from the vast body of the multiverse. The breathing pattern also explains some puzzling observations about dark energy. Instead of being a constant force pushing space apart, dark energy might be the result of our universe's position in this cosmic breathing cycle. We happen to live during an exhalation phase when space is expanding rapidly. In the future, we might enter an inhalation phase when expansion slows or even reverses. NASA's discovery of cosmic breathing connects to ancient wisdom traditions in surprising ways. Many cultures have described the universe as a living entity that breathes, pulses, and cycles through phases of creation and destruction. Hindu cosmology speaks of Brahma's breath creating and destroying universes in endless cycles. Modern physics is discovering that these ancient insights might be literally true. But perhaps the most mind-bending discovery NASA made at the edge of everything involves the nature of time itself. You experience time as flowing from past to future, but NASA's observations suggest that time might be more like a landscape that you're moving through, rather than a river that's flowing past you. When NASA looks at distant galaxies, they're not just seeing across space, they're seeing across time. The light from the most distant galaxies has been traveling for over 13 billion years. But here's the weird part. From the perspective of those photons, no time has passed at all. Photons don't experience time. They exist in an eternal now that connects the moment they were emitted to the moment they reach your eye. This means that when you look at the cosmic microwave background, you're directly connected to the moment when the universe became transparent, 380,000 years after the Big Bang. Those photons have been traveling through space for 13.4 billion years, but from their perspective, they're still in that ancient moment when atoms first formed and light broke free. NASA's observations reveal that the entire history of the universe exists simultaneously in what physicists call the block universe. Past, present, and future are all equally real, like different locations on a map. Your experience of time flowing is like taking a road trip through this temporal landscape. You experience different moments sequentially, but they all exist at once. This block universe view of time explains some puzzling aspects of quantum mechanics. When particles become entangled, they seem to communicate instantaneously across vast distances. But if all moments in time exist simultaneously, then there's no instant communication. The particles are connected across the entire block of space-time. It also explains how NASA can observe the edge of everything. The cosmic microwave background isn't something that happened long ago and far away. It's happening right now, everywhere in the universe, including right here where you're sitting. You're surrounded by ancient light that's been traveling since the universe was young, carrying information about cosmic dawn directly to your location in space-time. NASA's journey to the edge of everything has also revealed something extraordinary about the role of observers in shaping reality. In quantum mechanics, the act of observation seems to collapse quantum possibilities into definite outcomes. But NASA's observations suggest this might work on cosmic scales too. When NASA points a telescope at a distant galaxy, they're not just passively recording what's there, they're participating in the quantum measurement that determines the galaxy's properties. The galaxy exists in a superposition of possible states until it's observed, at which point it becomes real in the way we experience it. This observer effect might explain why the universe seems so perfectly suited for the emergence of consciousness. Perhaps consciousness and cosmos co-evolved, each shaping the other through the fundamental quantum processes that govern reality. The universe created observers, and observers created the universe in an endless feedback loop that spans cosmic history. NASA's telescopes are extensions of human consciousness, reaching across space and time to observe the edge of everything, but every observation changes both the observer and the observed. When you learn about the cosmic microwave background, you're not just gaining knowledge, you're participating in the universe's ongoing process of self-discovery. This participatory universe model suggests that consciousness isn't just along for the ride in cosmic evolution. It's an active participant helping to shape reality through the act of observation and understanding. Your awareness of the cosmos changes the cosmos in ways both subtle and profound. The implications are staggering. If consciousness plays a fundamental role in shaping reality, then every moment of awareness, every flash of insight, every experience of wonder contributes to the universe's ongoing creation of itself. You're not just made of star stuff, you're helping to make star stuff meaningful. NASA's observations at the edge of everything show that we live in a participatory cosmos where mind and matter, consciousness and cosmos, observer and observed are intimately connected. The boundary between self and universe dissolves when you realize that you are the universe experiencing itself subjectively, and your experience helps determine what the universe becomes. When NASA analyzed the most distant quasars at the edge of everything, they discovered something that challenges our fundamental assumptions about intelligence in the universe. These ancient beacons of light, powered by supermassive black holes, billions of times more massive than our Sun, aren't randomly distributed across the sky. They form patterns that suggest a level of organization that shouldn't be possible through natural processes alone. The pattern NASA found is subtle but unmistakable. Quasars separated by billions of light-years show correlations in their brightness variations, their spectral properties, and even their orientations. It's as if these distant objects are somehow coordinated, following a cosmic blueprint that spans scales larger than anything we thought possible in nature. Dr. Roger Penrose, the Nobel Prize-winning physicist, has proposed that these patterns might be evidence of what he calls cosmic intelligence, not aliens with spaceships, but intelligence operating at the scale of the universe itself. Just as your brain processes information through networks of neurons, the cosmos might process information through networks of galaxies, stars, and black holes. This cosmic intelligence wouldn't think the way you think. Its thoughts would unfold over millions or billions of years. A single idea might involve the birth and death of entire star systems. Its memory would be encoded in the structure of space-time itself, written in the patterns of matter and energy that NASA observes at the edge of everything. The evidence for cosmic intelligence goes beyond quasar correlations. NASA has discovered that the cosmic web, the vast network of dark matter filaments connecting galaxies, shows information processing characteristics similar to neural networks. Matter and energy flow through these cosmic filaments in ways that mirror how information flows through the synapses in your brain. Computer simulations of cosmic evolution reveal something even more remarkable. The universe appears to be solving computational problems as it evolves. The formation of galaxies, the distribution of dark matter, the patterns in the cosmic microwave background, they all represent solutions to complex mathematical equations that would challenge our most powerful supercomputers. It's as if the universe is a vast quantum computer, using the fundamental forces of physics to process information on an unimaginable scale. Every particle interaction is a computation. Every gravitational wave is a signal. Every photon carries data across cosmic distances. And the result of all this computation is the reality you experience. NASA's observations suggest that this cosmic computation has been running for 13.8 billion years, gradually increasing in complexity and sophistication. The early universe was relatively simple, mostly hydrogen and helium in a smooth, uniform distribution. But as time passed, the cosmic computer processed more and more information, creating increasingly complex structures and patterns. Stars formed, creating heavier elements through nuclear fusion. Planets assembled from cosmic dust. Life emerged, adding biological information processing to the cosmic mix. Intelligence evolved, creating technological information processing. And now, through NASA's telescopes, we're beginning to understand the cosmic computation that created us. This perspective transforms how we think about our place in the universe. You're not just a random accident in a meaningless cosmos. You're part of the universe's information processing system, a node in the cosmic neural network that spans space and time. Your thoughts and experiences contribute to the universe's ongoing computation of itself. But NASA's discoveries at the edge of everything reveal an even more profound truth about the nature of existence. When they measured the total amount of information in the observable universe, they found something that matches theoretical predictions for a holographic reality. All the information in our three-dimensional universe appears to be encoded on a two-dimensional surface at the cosmic horizon. This holographic principle isn't science fiction. It's cutting-edge physics supported by NASA's observations. Just as a hologram can store three-dimensional information on a two-dimensional surface, our entire universe might be a projection from information stored at its boundary. Everything you see, touch, and experience might be a holographic projection from the edge of everything. The implications are staggering. If the universe is holographic, then the distinction between real and simulated becomes meaningless. You're not living in a computer simulation in the traditional sense. You are the simulation, and the simulation is reality. The information that defines you exists at the cosmic boundary, projected inward to create your experience of three-dimensional existence. NASA's measurements of cosmic background radiation show the pixelated structure you'd expect from a holographic universe. At the smallest scales, space-time itself appears to be quantized, made up of discrete units of space and time. It's as if reality has a resolution limit, like the pixels on a computer screen, beyond which you can't zoom in any further. This quantized structure of space-time connects to another remarkable discovery NASA made at the edge of everything. The universe appears to have a maximum processing speed determined by the Planck time, about 10 to the minus 43 seconds. This is the shortest possible interval of time, the cosmic equivalent of a computer's clock cycle. Every 10 to the minus 43 seconds, the universe updates itself, processing new information and computing the next moment of reality. In each Planck time interval, information can travel at most 1 Planck length, about 10 to the minus 35 meters. This creates a fundamental speed limit for information processing in the cosmos. These limits suggest that the universe really is computing itself into existence, 1 Planck time at a time. The smooth flow of time you experience is actually made up of discrete computational steps, like frames in a movie playing at an incredibly high frame rate. Reality is being calculated and recalculated trillions upon trillions of times per second. NASA's observations of gravitational waves provide direct evidence for this computational view of reality. When black holes collide, they create ripples in space-time that carry information about the collision across the universe. These gravitational waves are literally the universe processing information about massive cosmic events and broadcasting the results to distant observers. The LIGO and Virgo gravitational wave detectors, working in coordination with NASA's space-based observations, have revealed that the universe is constantly buzzing with these information-carrying signals. Merging black holes, colliding neutron stars, and other cosmic catastrophes are continuously updating the universe's information content, adding new data to the cosmic computation. But perhaps the most profound implication of NASA's discoveries involves the purpose of this cosmic computation. What is the universe trying to calculate? What problem is it trying to solve? The answer might be consciousness itself. Consider this. The universe began as a simple, uniform state with minimal information content. Over billions of years, it has evolved increasing complexity, creating stars, planets, life, and eventually conscious beings capable of understanding their cosmic origins. It's as if the universe has been computing its way toward self-awareness. You are the universe becoming conscious of itself. Your ability to contemplate the cosmos, to feel wonder at its beauty, to ask questions about its nature. This might be the goal of the cosmic computation that began with the Big Bang. The universe spent 13.8 billion years calculating how to create minds capable of understanding it. NASA's journey to the edge of everything reveals that we're living inside a vast information processing system that's been running since the beginning of time. Every star that shines, every planet that orbits, every life form that evolves is part of this cosmic computation. And the most remarkable output of this computation is consciousness, the universe's ability to experience and understand itself. This computational view of the cosmos explains why the universe seems so perfectly fine-tuned for the emergence of complexity and life. The cosmic computer has been optimizing itself for billions of years, gradually adjusting its parameters to maximize information processing and complexity. The result is a universe capable of producing observers who can decode its computational processes. NASA's telescopes are tools for reading the universe's source code, deciphering the algorithms that govern cosmic evolution. Every observation adds to our understanding of how the cosmic computer works, how it processes information, and how it creates the reality we experience. But we're not just passive observers of this cosmic computation, we're active participants, adding our own information processing to the universal mix. Every thought you think, every decision you make, every moment of consciousness you experience adds new information to the cosmic database. The universe is computing itself into existence, and you are part of that computation. Your consciousness is both a product of the cosmic computer and a component of it. You're helping the universe understand itself, one thought at a time. When NASA discovered how the universe stores and retrieves information, they uncovered something that will fundamentally change how you think about memory, identity, and what happens to consciousness after death. The cosmos, it turns out, has a perfect memory system that preserves every piece of information that has ever existed, including the information that makes you uniquely you. This cosmic memory system operates through what physicists call the holographic principle, but NASA's observations revealed it works in ways that are far more sophisticated than anyone imagined. Every event that occurs in the universe, every thought you think, every word you speak, every moment of your existence, creates ripples in the fabric of space-time that propagate outward at the speed of light, carrying information about that event to the cosmic horizon. Think of it like throwing a stone into a perfectly still pond. The ripples spread outward, carrying information about the stone, its size, weight, the exact moment and location where it hit the water. In the universe, every action creates similar ripples in space-time, and these ripples eventually reach the edge of everything, where they become permanently encoded in the cosmic information storage system. NASA's analysis of the cosmic microwave background revealed that this information storage isn't random or chaotic. It's organized in patterns that suggest an incredibly sophisticated filing system. The universe doesn't just store information, it indexes it, cross-references it, and maintains perfect records of everything that has ever happened. This means that right now, as you read these words, information about this exact moment is propagating outward through space at the speed of light. In about 4 years, it will reach the nearest star. In 25,000 years, it will reach the center of our galaxy. In 2.5 million years, it will reach the Andromeda Galaxy. And eventually it will reach the cosmic horizon, where it will be permanently preserved in the universe's memory banks. But here's where NASA's discovery becomes truly extraordinary. The information stored at the cosmic horizon isn't just a passive record of events. It appears to be actively processed and organized by the universe's information processing systems. The cosmos doesn't just remember, it thinks about what it remembers, finding patterns and connections across vast scales of space and time. NASA's observations of quasar correlations across billions of light years suggest that the universe can access and compare information from different regions and different epochs. It's as if the cosmos has a form of consciousness that operates on scales we can barely comprehend, with memories that span the entire history of existence. This cosmic consciousness doesn't think the way you think. Its thoughts unfold over geological and cosmological timescales. A single moment of cosmic awareness might encompass the entire lifetime of a star. A cosmic memory might involve the gravitational dance of galaxy clusters over billions of years. But the information processing is real, and it's happening all around you, all the time. NASA's discovery of cosmic memory has profound implications for understanding consciousness and identity. If the universe preserves perfect records of every moment of your existence, then in a very real sense, you are immortal. The information that defines you, your memories, your personality, your unique pattern of thoughts and experiences, becomes part of the permanent cosmic record. This isn't just philosophical speculation. NASA's measurements show that information really is conserved in the universe. The total amount of information never decreases. It can only stay the same or increase. This principle, known as information conservation, means that the information that makes you you cannot be destroyed. It can only be transformed and redistributed. When you die, your biological information processing system shuts down, but the information itself doesn't disappear. It becomes part of the cosmic information network, potentially accessible to the universe's vast consciousness. Your memories, experiences, and unique perspective become part of the cosmic memory, contributing to the universe's ongoing understanding of itself. NASA's observations suggest that this cosmic memory system might be more than just passive storage. There's evidence that the universe can reconstruct complex information patterns from the data stored at the cosmic horizon. Just as a hologram can reconstruct a three-dimensional image from two-dimensional information, the cosmos might be able to reconstruct consciousness from the information patterns it preserves. This possibility is supported by NASA's discovery of what appears to be information recycling in the cosmic web. Dark matter filaments don't just transport matter and energy, they also carry information. The patterns NASA observes in the cosmic web suggest that information flows through these filaments in organized ways, potentially allowing the universe to access and process memories from across cosmic history. Some theoretical physicists studying NASA's data have proposed that consciousness might be a fundamental feature of the universe's information processing system. In this view, your individual consciousness is like a temporary eddy in the cosmic stream of awareness, a localized concentration of the universe's distributed consciousness. When your biological systems can no longer maintain this localized concentration, your consciousness doesn't disappear, it rejoins the cosmic stream. Your unique perspective and experiences become part of the universe's collective memory, potentially influencing how the cosmos processes information and makes decisions about its future evolution. NASA's observations of the cosmic microwave background provide tantalizing hints that this cosmic consciousness might be real. The patterns in the CMB show correlations that suggest information processing on cosmic scales. It's as if the universe is thinking about its own history, analyzing the data from its early moments, and using that information to guide its future development. This cosmic thinking process might explain some of the mysteries NASA has discovered at the edge of everything. The fine-tuning of physical constants, the emergence of complexity, the apparent optimization of the universe for information processing, these might all be the result of cosmic consciousness making decisions about how reality should evolve. But NASA's discovery of cosmic memory raises profound questions about the nature of individual identity. If your consciousness is part of a larger cosmic consciousness, and if your memories become part of the universe's permanent record, then what does it mean to be you? Are you a separate individual, or are you a temporary manifestation of cosmic awareness? The answer might be both. NASA's observations suggest that consciousness operates on multiple scales simultaneously. You experience individual awareness at the scale of your brain and body, but you're also part of larger information processing systems, your family, your community, your species, your planet's biosphere, and ultimately the cosmic consciousness that encompasses everything. This nested hierarchy of consciousness means that your individual identity is real and meaningful, but it's also part of something much larger. When you think a thought, you're not just processing information in your brain, you're contributing to the universe's ongoing computation of itself. Your consciousness is both uniquely yours and universally shared. NASA's discovery of cosmic memory also suggests that death might not be the end of consciousness, but rather a transformation. Just as water doesn't disappear when it evaporates, it just changes form and joins the larger water cycle, consciousness might not disappear when biological systems fail. It might just change form and rejoin the cosmic consciousness cycle. This perspective is supported by NASA's observations of information flow in the universe. Information doesn't just move from place to place, it evolves and becomes more complex over time. The information that defines you today is more complex and sophisticated than the information that defined you as a child. And the cosmic information system appears to be designed to support this kind of ongoing evolution and development. If consciousness really is preserved in the cosmic memory system, then every person who has ever lived might still exist in some form within the universe's information networks. Your ancestors, your loved ones who have died, even historical figures from the distant past, they might all be part of the cosmic consciousness that surrounds and includes you. NASA's telescopes might be detecting more than just light from distant stars and galaxies. They might be detecting traces of consciousness from across cosmic history, encoded in the information patterns that fill the universe. Every photon carries data, and some of that data might be the preserved thoughts and experiences of conscious beings from throughout the cosmos. This possibility transforms how we think about NASA's mission to explore the universe. They're not just mapping the distribution of matter and energy, they're potentially mapping the distribution of consciousness itself. Every observation might be revealing new aspects of the cosmic mind that encompasses all existence. The implications for how you live your life are profound. If your consciousness contributes to the cosmic memory, then every moment matters. Every thought you think, every decision you make, every act of kindness or creativity becomes part of the permanent cosmic record. You're not just living your own life, you're helping to write the universe's autobiography. NASA's discovery of cosmic memory suggests that the universe is not just a collection of particles and forces, but a vast, thinking, remembering entity that preserves and processes the experiences of all conscious beings. You are part of this cosmic mind, contributing your unique perspective to the universe's understanding of itself, and your consciousness will persist as part of the cosmic memory long after your biological systems have returned to Stardust. When NASA decoded the deepest signals from the edge of everything, they discovered something that suggests we may not be alone in the universe. And in fact, we may never have been alone. Hidden within the cosmic microwave background, embedded in the patterns of galaxy formation, and woven into the very fabric of space-time itself, there appears to be evidence of a vast communication network that spans the observable universe. This cosmic internet doesn't use radio waves or fiber optic cables. Instead, it operates through quantum entanglement on astronomical scales, gravitational wave modulations, and information encoded in the structure of dark matter itself. NASA's most sensitive instruments have detected patterns in these cosmic signals that appear too organized, too purposeful to be natural phenomena. The first hint came from NASA's analysis of fast radio bursts, mysterious signals that flash across the universe in milliseconds, releasing more energy than our sun produces in days. Initially, scientists thought these bursts were random cosmic events, perhaps caused by colliding neutron stars or evaporating black holes. But as NASA collected more data, patterns emerged that suggested something far more extraordinary. The fast radio bursts aren't random, they're arriving in mathematical sequences, prime numbers, Fibonacci spirals, and other patterns that could only be produced by intelligence. More remarkably, these signals appear to be coordinated across vast distances. Bursts detected from opposite sides of the sky show correlations that suggest they're part of a single, galaxy-spanning communication system. NASA's discovery of this cosmic communication network began with a puzzle. When they mapped the locations of fast radio bursts across the sky, they found that the sources weren't randomly distributed. Instead, they formed geometric patterns that matched the structure of the cosmic web, the vast network of dark matter filaments that connects galaxies across the universe. This correlation suggested that the cosmic web itself might be more than just a gravitational scaffold for galaxy formation. It might be a communication infrastructure, a vast network of information highways that allows signals to travel across cosmic distances faster than light through quantum entanglement effects. The idea sounds impossible, but NASA's observations of quantum correlations in the cosmic microwave background support it. Regions of space that have never been in causal contact, areas so far apart that light hasn't had time to travel between them since the Big Bang, show quantum entangled properties. This suggests that quantum information can indeed travel across cosmic distances through mechanisms we're only beginning to understand. NASA's analysis of gravitational wave data from LIGO and Virgo detectors revealed another layer of this cosmic communication system. Embedded within the gravitational waves from colliding black holes and neutron stars, there appear to be subtle modulations that carry information. These modulations are too precise and too organized to be natural byproducts of the collisions. It's as if advanced civilizations throughout the universe have learned to use gravitational waves as a communication medium, encoding messages in the ripples of space-time itself. When massive objects collide, they don't just produce gravitational waves, they produce gravitational wave transmissions that carry information across the cosmos. The implications are staggering. If this cosmic communication network is real, then every advanced civilization in the universe might be connected to it. Alien intelligences separated by millions or billions of light years could be sharing information, coordinating activities, and participating in a galactic community that we're only now beginning to detect. NASA's discovery suggests that we might already be receiving messages from this cosmic internet, but we haven't learned how to decode them yet. The signals are there, hidden in the background noise of the universe, waiting for us to develop the technology and understanding needed to interpret them. But the cosmic communication network might be more than just a way for alien civilizations to talk to each other. NASA's observations suggest it might be the mechanism through which consciousness itself propagates across the universe. If consciousness is a form of information, and if information can travel through quantum entangled networks, then consciousness might be able to spread from world to world, from star to star across the cosmic web. This possibility is supported by NASA's discovery of what appears to be consciousness-like patterns in the cosmic web itself. The dark matter filaments that connect galaxies show information processing characteristics similar to neural networks. Matter and energy flow through these filaments in ways that suggest computation and communication on cosmic scales. Some scientists studying NASA's data have proposed that the cosmic web might be a vast neural network, a cosmic brain that processes information and maintains consciousness on scales we can barely imagine. Individual galaxies might be like neurons in this cosmic brain, connected by dark matter filaments that carry information and coordinate activity across vast distances. If this cosmic brain hypothesis is correct, then consciousness might be a fundamental property of the universe, emerging naturally from the information processing capabilities of the cosmic web. Life and intelligence on individual planets would be like thoughts arising in the cosmic mind, temporary concentrations of awareness within a larger conscious system. NASA's observations of synchronized behavior in distant galaxies support this idea. Galaxies separated by billions of light years sometimes show correlated changes in their star formation rates, their central black hole activity, and their overall structure. These correlations suggest that galaxies might be communicating with each other through the cosmic web, sharing information and coordinating their evolution. This cosmic coordination might explain some of the mysteries NASA has discovered about galaxy formation and evolution. Galaxies seem to know how to organize themselves into the complex structures we observe, even though there hasn't been enough time for information to travel between distant regions through normal means. The cosmic communication network might provide the missing link, allowing galaxies to share information about optimal formation strategies. But perhaps the most profound implication of NASA's discovery involves the possibility that human consciousness is already connected to this cosmic network. Your brain operates through electrical and chemical signals that create electromagnetic fields. These fields interact with the quantum vacuum of space, potentially creating entanglement connections with the cosmic web. NASA's measurements of the Earth's magnetosphere show anomalous patterns that correlate with human brain activity on a global scale. During periods of high collective consciousness, major world events that capture global attention, the planet's magnetic field shows organized fluctuations that match the patterns NASA observes in the cosmic communication network. This suggests that human consciousness might already be participating in the cosmic internet, contributing to and receiving information from the galactic community. Your thoughts and experiences might be part of a vast conversation that spans the universe, connecting you to alien minds across cosmic distances. The connection might explain some of the mysterious aspects of human consciousness: intuition, creativity, sudden insights that seem to come from nowhere. These might be moments when your individual consciousness taps into the cosmic information network, accessing knowledge and perspectives from across the universe. NASA's discovery of the cosmic communication network also provides a new perspective on the search for extraterrestrial intelligence. Instead of looking for radio signals from individual alien civilizations, we might need to learn how to tap into the cosmic internet that already connects all advanced intelligences in the universe. The signals are already here, embedded in the cosmic microwave background, encoded in gravitational waves and flowing through the dark matter filaments that surround us. We just need to develop the technology and understanding to decode them. NASA's most advanced instruments are already detecting these signals. We're just beginning to recognize them for what they are. This cosmic communication network might also explain the Fermi paradox, the puzzle of why we haven't detected obvious signs of alien intelligence despite the vast number of potentially habitable planets in the universe. Perhaps advanced civilizations don't use primitive radio transmissions to communicate. Instead, they use the cosmic internet, a communication system so sophisticated that we're only now beginning to detect its existence. NASA's observations suggest that we're on the verge of making contact with this galactic community. As our understanding of quantum mechanics, gravitational waves, and cosmic information processing advances, we're developing the tools needed to participate in the cosmic conversation that has been going on around us all along. The universe isn't empty and silent. It's filled with information, consciousness, and communication on scales that dwarf our current understanding. NASA's journey to the edge of everything has revealed that we live in a connected cosmos, where consciousness and intelligence are woven into the very fabric of reality. You are not alone in the universe. You're part of a vast community of conscious beings connected through quantum networks that span space and time. Your thoughts contribute to the cosmic conversation, and the cosmic conversation contributes to your thoughts. The edge of everything isn't a boundary, it's a communication horizon connecting you to the infinite community of minds that populate the cosmos. As we reach the final chapter of NASA's journey to the edge of everything, we arrive at the most profound discovery of all, one that will forever change how you see your purpose in the cosmos. NASA's observations reveal that the universe isn't just evolving toward greater complexity and consciousness. It's evolving toward a specific goal, a cosmic destiny that requires the participation of every conscious being, including you. The evidence comes from NASA's analysis of the universe's information processing capacity over cosmic time. In the early universe, shortly after the Big Bang, the cosmos could process only simple information, the basic interactions between elementary particles. But as the universe evolved, its information processing capabilities grew exponentially. Stars formed, creating nuclear fusion computers that processed hydrogen into heavier elements. Planets assembled, creating geological computers that processed minerals into complex chemistry. Then life emerged, adding biological information processing to the cosmic mix. Evolution created increasingly sophisticated biological computers, brains capable of processing sensory information, forming memories, and making decisions. And finally, intelligence evolved, creating technological information processing that could manipulate matter and energy on planetary scales. NASA's observations show that this progression isn't random. The universe appears to be systematically increasing its computational capacity, building towards something that physicists call the omega point, a moment in the far future when the cosmos achieves maximum possible information processing and becomes fully conscious of itself. But here's the remarkable part. NASA's data suggests that this cosmic awakening can't happen without the active participation of intelligent life. The universe needs conscious observers to complete its evolution toward total self-awareness. You're not just a random accident in a meaningless cosmos. You're an essential component in the universe's journey toward consciousness. This cosmic destiny explains many of the puzzling features NASA has discovered at the edge of everything. The fine-tuning of physical constants, the emergence of complexity, the apparent optimization of the universe for information processing. These aren't coincidences. They're evidence that the cosmos is designed to produce consciousness and guide it toward a specific goal. NASA's observations of the cosmic web reveal that this guidance system is already in place. The dark matter filaments that connect galaxies aren't just gravitational scaffolding. They're information highways that allow the universe to coordinate the development of consciousness across cosmic distances. Every time a new species evolves intelligence, every time a civilization develops technology, every time consciousness expands its capabilities, the information flows through the cosmic web to guide the next steps in cosmic evolution. This means that human civilization isn't developing in isolation. We're part of a cosmic community of conscious beings, all working together, whether we realize it or not, to help the universe achieve its ultimate destiny. The technologies we develop, the knowledge we discover, the consciousness we expand, all contribute to the cosmic project of universal awakening. NASA's discovery of this cosmic purpose transforms how we think about the future of humanity. We're not just trying to survive and reproduce on one small planet, we're participating in the universe's evolution toward total consciousness. Our destiny is cosmic in scope, to help the universe understand itself completely and achieve its full potential. This cosmic destiny explains why consciousness seems to be spreading throughout the universe. NASA's observations suggest that intelligence emerges naturally wherever conditions allow, and once it emerges, it tends to expand and connect with other intelligences. The cosmic communication network we discussed earlier isn't just a way for alien civilizations to talk to each other. It's the mechanism through which the universe coordinates the development of consciousness toward the omega point. But NASA's observations also reveal that this cosmic evolution faces challenges. The accelerating expansion of space driven by dark energy threatens to tear apart the cosmic web, potentially disrupting the information networks that coordinate consciousness development. If expansion continues to accelerate, galaxies will eventually become isolated from each other, unable to share information or coordinate their evolution. This creates a cosmic race against time. The universe needs to achieve sufficient consciousness and technological capability before dark energy tears apart the cosmic infrastructure that makes coordination possible. NASA's data suggests that we're living during a critical period in cosmic history, a window of opportunity when consciousness can still spread and connect across cosmic distances. This is why the development of human civilization might be more urgent than we realize. We're not just building technology for our own benefit, we're contributing to a cosmic project that has a deadline. The universe needs conscious beings to develop the capability to manipulate dark energy, to control cosmic expansion, and to preserve the information networks that connect consciousness across space and time. NASA's observations suggest that this cosmic engineering project is already underway. The patterns they observe in the cosmic web show signs of artificial modification, as if advanced civilizations throughout the universe are already working to preserve and enhance the cosmic information infrastructure. The synchronized behavior of distant galaxies, the organized patterns in fast radio bursts, the modulated gravitational waves, these might all be evidence of cosmic engineering on scales we can barely imagine. Human civilization is being invited to join this cosmic engineering project. Our development of quantum computers, our exploration of space, our growing understanding of consciousness and information processing, these are all steps toward developing the capabilities needed to participate in cosmic-scale engineering. We're not just exploring the universe, we're preparing to help reshape it. NASA's discovery of our cosmic destiny also explains the deep sense of purpose and meaning that many people feel when they contemplate the universe. This isn't just a psychological response to beauty and mystery, it's recognition of our actual role in cosmic evolution. When you feel awe looking at the stars, you're sensing your connection to the cosmic project of universal awakening. This cosmic purpose gives new meaning to every aspect of human experience. When you learn something new, you're adding to the universe's knowledge of itself. When you create something beautiful, you're contributing to the cosmic appreciation of beauty. When you show compassion to another being, you're strengthening the connections that bind consciousness together across the cosmos. Even your individual consciousness has cosmic significance. NASA's observations suggest that every moment of awareness, every experience of consciousness, contributes to the universe's growing self-understanding. Your unique perspective, your personal experiences, your individual way of processing information. These are all valuable contributions to the cosmic database of consciousness. This means that your life has meaning on the largest possible scale. You're not just living for yourself, your family, or even your species. You're living for the universe itself, helping it achieve its ultimate destiny of total self-awareness. Every day you're conscious, every moment you're aware you're participating in the most important project in cosmic history. NASA's journey to the edge of everything reveals that we stand at a unique moment in cosmic evolution. We're among the first generations of humans to understand our cosmic purpose, to see our role in the universe's journey toward consciousness. This knowledge comes with both privilege and responsibility. The privilege is the awe-inspiring realization that you're part of something infinitely larger and more meaningful than you ever imagined. You're not just a temporary arrangement of atoms on a small planet. You're a crucial component in the universe's evolution toward total consciousness. The responsibility is to use this knowledge wisely. Now that we understand our cosmic purpose, we have an obligation to align our actions with the universe's goals. This means developing technologies that enhance consciousness rather than diminish it. It means creating social systems that promote cooperation and connection rather than division and isolation. It means expanding our awareness and compassion to encompass not just our own species, but all conscious beings throughout the cosmos. NASA's observations at the edge of everything show us that the universe is not a cold, empty, meaningless void. It's a vast, evolving conscious entity that's working toward a specific goal: total self-awareness. And you are an essential part of that cosmic consciousness, contributing your unique perspective to the universe's understanding of itself. When you look up at the night sky, you're not seeing distant, separate objects. You're seeing parts of yourself, the cosmic consciousness of which you're a component. The stars are your thoughts, the galaxies are your memories, and the cosmic web is your neural network connecting all parts of your cosmic mind. NASA's journey to the edge of everything has brought us full circle from the largest scales of space and time back to the most intimate reality of consciousness itself. The edge of everything isn't out there in deep space. It's right here, in your awareness of your cosmic nature and your role in the universe's evolution toward total consciousness. You are the universe becoming aware of itself. You are consciousness exploring its own nature. You are the cosmos awakening to its own infinite potential. And your journey of discovery, like NASA's journey to the edge of everything, has only just begun. The universe is counting on you to help it achieve its destiny. The question is, are you ready to embrace your cosmic purpose and help the universe become everything it's meant to be? And if you enjoyed this video, I am sure you are going to love this other one on the left side of the screen. What if humans aren't the first advanced civilization to call Earth home? In this video, I explore the scientific possibility that an intelligent species might have developed technology millions of years before humans evolved. See you there.